Hello, my name's Mike. Welcome to the secret life of the tree. If you're ever going to be an effective woodworker, you are going to need to understand the material itself. And to do that, we must begin at the beginning with the growth and the structure of the tree. And so for the next few minutes, I'm going to be talking to you about that. I'm going to be referring to this diagram on the board here, but if you find that you're unable to see that, don't be too concerned about that, because you'll be given the opportunity to see it in greater detail later on in the course. Well, timber, a beautiful, natural material, and absolutely fascinating to work with, and something that will fascinate you as it has done me for the last 40 years. So let's begin at the beginning. I'm sure that I don't need to explain to anyone here the material that's around the edge of a tree trunk. That is familiar to even the youngest school child. And of course that is the bark material. And the bark is there to protect the outside of the tree, and particularly a layer that is just under the bark, which is the life of the tree, which is going to ensure that the tree grows and develops as it should. So the bark around the edge gives it that vital protection. Well, just underneath the bark, you will discover that there is a very important layer which woodworkers call the cambium, or the bast layer. And the bast layer is the factory in which all of the cells for the tree are produced. And you will see, if you look a little bit carefully at the edge of my piece of wood here, you'll see a whole load of little tracks around the edge there. And those have been created by wood-boring insects who have found that cambium layer just under the bark a valuable source of food for them. And so that is the factory layer, the layer that produces all of the cells that increases the diameter and the height of the tree trunk. Now, as we move in, you'll all be familiar with the fact that a tree produces annual rings. And you will have learnt in primary school that each year a tree produces an annual ring. However, when you begin to understand things a little bit more clearly, you'll begin to realise that a tree, especially a tree that grows in either the northern hemisphere or in the southern hemisphere, where there are clear distinctions between spring and summer and autumn and winter growth, actually produces two rings. It will produce a ring during the spring and the summertime, which generally is wider and bigger and more open-celled than the ring that is produced during the autumn and the winter. And if you have a little look at my sliver here, my transverse cut, you will see that there is a narrow ring, and then in between it there's quite a large ring before you encounter another of those narrow rings. Now, of course, the wide ring is the spring and summer growth, where the cells are more open and more of them are produced. The narrower ring alongside it is the autumn and winter growth. And because the growth of the tree is a lot slower during that time, the cell walls are thicker, and so a denser and usually darker ring is produced. So we have the annual rings, and I've represented those on the screen by the black line and the gap between the black line, and they are the annual rings collectively, and they're separated out on the diagram here with the autumn and winter growth pointing to the line, and the spring and the summer growth, which is over here, which is the wider growth, the wider ring. Okay? So those are the annual rings. And as I said, in what we call a maritime climate, a climate where there's a clear distinction between spring and summer and autumn and winter, you'll get those two types of growth. In tropical trees, however, growth is fairly consistent throughout the year, and so there isn't that clear distinction in the cellular structure producing the annual rings as we know them here in Britain and North America and those areas and down in New Zealand. So, those are the annual rings. Now, in addition to that, right in the centre of the tree, you will find the original sapling from which the tree originally grew, right there in the centre of the tree. And in pieces of softwood, you often see running down the middle of it a dark brown line which looks a little bit like bark. Well, in actual fact, that's what it is. It's the original sapling from which the tree grew. And we call that the pith, right in the centre of the tree. So here we have some of the basic structures of the tree. Now, in addition to that, we divide up the tree into two main components. At the centre here, and generally darker in colour, we have what is commonly known as the heartwood. Now, the heartwood doesn't fulfill any function in terms of the growth of the tree. It's there to provide stability and structure, in other words, to keep the tree vertical. And I have a sliver, a transverse cut, just like the one you've seen in that beautiful piece of elm over there, and the centre of it has been eaten away by rot. And yet when we felled that tree, it was growing perfectly, because the outer layer that we're going to talk about in a moment was still intact, and the cambium layer was still intact, and therefore the tree was continuing to grow, though it had rotted from the centre. The heartwood had completely gone. So that heartwood in the centre forms the structure of the tree and helps to keep it upright. And each year, one pair of annual rings becomes part of the heartwood. And on the outside of the tree trunk, another minimum of one pair of rings is produced on the outside section, which is the light section, produced by the bast or the cambium layer, and that is known as the sapwood. The sapwood. Now, the sapwood is the living part of the tree. It's that area where the cells have been added on the outside by the cambium and the bast layer. And of course, it still has a lot of nutrients in it, and that makes sapwood very attractive for wood-boring insects and woodworm and other insects, because it's a source of food. So, if you were to talk to one of my students in one of the wood turning classes, Bob, he would tell you that in the furniture industry, they very rarely use the sapwood of the tree trunk because of its tendency to rot more, its attractiveness to insects, and of course too, it's not as hard as the heartwood. However, if you're a wood turner, that often provides some of the most attractive pieces of timber to work with. So if you were to take, for example, a piece of English yew. A piece of English yew has a vivid, bright tango orange heartwood, but surrounding the edges of it, it has an almost pure white sapwood, and that gives a beautiful contrast when you're woodworking, and particularly if you're wood turning, because all sorts of shapes and patterns and forms are created by the grain structure. Take another tree, Wengi. Wengi, an African tropical hardwood. It's almost chocolate brown in colour, but around the edge of it is an almost pure white sapwood, and so that provides a very, very attractive contrast when you're wood turning particularly. Although, as I said, in the furniture making industry, even to today, they're still avoiding using the sapwood and concentrating in the main on the heartwood. Now, I've mentioned already that at least one pair of rings, one autumn, spring and summer, autumn and winter, one spring and summer ring is added to the heartwood. But of course, given environmental conditions, a tree can put on more than one pair of rings around the outside on the sapwood each year. For example, if say we have a relatively warm winter, and the tree thinks, well, it's warming up, we can go into spring and summer growth. And then suddenly in April or May time, it gets very cold again. Then at that point, it will go back into autumn and winter growth mode. And then, of course, when summer comes for real, it will then go back into fall, spring and summer growth. But it will have produced more than one pair of annual rings. And that means that we have to be just a little bit careful with dendrochronology, working out dates from tree rings, because you only have to have a couple of years in which there are those environmental conditions that give us the opportunity for more than one pair of rings, and all of your dating can be out. However, what you can clearly tell is the weather that year from the annual rings. And if you look on this particular tree trunk here, you will see, if I lift it up a little bit, there's a particularly wide spring and summer ring there. And if you were to trace it all the way around to the other side, you would find that it was particularly narrow. And you wonder why that might have happened. Well, that could be to do with environmental conditions, but more often than not, it's to do with the fact that there are other trees close to it, and therefore the tree is unable to put on extra material on that outer side nearest the other tree, and yet it can produce a lot of material on the other side of the tree where there's more space. So environmental conditions can make the spring and summer annual ring growth very, very large, or the place, the location where it is, and whether there are other trees in close proximity to it can also determine whether and how much the tree produces on the outside. And as I said, a minimum of one pair of annual rings is added onto the external diameter of the tree each year, and generally just one pair is added to the heartwood. However, there is still one last very, very important thing that we need to consider. You will, I hope, notice on this diagram over here that there are lines running, radiating out from the centre. Now those lines are cells. They're cells that are running in the opposite direction to the normal direction of the cells. So in our tree trunk, if I give you another piece of timber here, the annual rings would be on the top and on the bottom, and the cells would be running vertically up and down in it. However, with these cells that radiate from the centre outwards, they are cells that are going in the opposite plane. And so you've got the cells of the tree running in that direction, and these cells cut across them and radiate from the centre of the tree. And those are known as the medullary ray cells. The medullary ray cells. Now you may ask why that is important. Well, it's important for this reason. I have here a little piece of oak, and what you will see is the medullary ray cells running in the contrary direction at almost right angles to the other cells running vertically through the tree trunk. And that produces what we call figure within timber. The medullary ray cells flicker in the lights because they're going in the opposite direction. And as a consequence, the timber merchant or the sawyer can charge a lot more for material that has been cut to expose those medullary rays. Now in a later lecture we will explain to you how on earth you cut a tree trunk to expose the medullary rays. But most, if not all, trees have medullary rays. However, they're not clearly defined in all trees. So, for example, the piece of oak that I've just shown you has clearly defined medullary rays. So does beech, and also to maple and sycamore. In fact, some of you will have seen figuring in maple already, though you may not have realised it. If you look on the back of a violin, you will see that rippled effect. And that is what is known as fiddleback maple. That is created by deflections in the grain and cells running in the opposite direction that create that phenomena known as fiddleback. However, if you were to have a piece of ash, its medullary rays are not visible at all. And therefore, it's not worth the sawyer cutting it in a more complicated and a more difficult way in order to expose the medullary rays as it would be with a piece of oak, which has these clearly defined medullary ray cells. So, this is the basic structure of the tree. These are the basic components of it, and I've given you just a little bit of background on them so that you can get your head around it, and hopefully as we move on with the course you'll begin to understand how this is relevant to actually working with the material so that you can understand the material more, and as a result you can become a more effective woodworker.